Welcome back to my channel, everyone. Retips here, and I haven't put a video out in a while, and so I figured I'd go ahead and include this short video on gold refining. If you look down in there, I've got the gold boiling in hot dilute nitric acid. It's been quartered with silver, and this is the fourth nitric acid boil. It's got a strange color to the liquid there. You'll notice it's got a little bit of an amber tint to it. And I had some white gold items in there, so there's probably going to be a little bit of palladium in with my gold. Palladium is the only one of the 6 sister metals in the platinum group that will dissolve in just nitric acid. While I'm waiting for this fourth nitric boil back here, what I'll do is add some more sterling silver to my silver jar here. The nitric boil gets poured off into my silver jar, and I make sure that there's plenty of sterling silver in there to consume the excess nitric that's in that solution. Nitric boil number 4 is pretty much complete here. You can tell that I've still got some silver and copper down in there by the color of the liquid. Now what we're going to do is we're going to pour this off into this container. This is going to make a lot of fumes, man. Hot nitric. As soon as it hits that silver, see it's making quite a bit of fumage there. I don't know how much of this I'm going to be able to pour in all at once like this. If I add too much, it could cause it to boil over. Alright, I'm going to let it go right there for a minute. Let's go ahead and continue to pour some of this in here. See, I've got to refine this silver anyway. I've got to dissolve it anyway, so I might as well use it to consume the rest of the nitric acid in these nitric boils. You can see there that the metal's just dissolving away as I pour that hot acid on it. Keeping a watch down lower down here. Make sure I don't get a bunch of bubbling. I see a bunch of bubbling, that means that we're getting too highly concentrated with acid. I've got to back it up, and I put so much in there. I think we're going to be okay getting all this in there. You can see down in there it's kind of foaming up now, so I'm going to stop right there, and maybe we'll add some to our other silver jar here in the back. Alright, this one seems to have calmed down quite a bit, so what I think I'm going to do is just continue getting the rest of the acid off of our quartered gold here. This is distilled water. I'm rinsing the gold off with distilled water now. We'll pour those rinses right in here. It's going to contain a little bit of nitric acid. All right, that was nitric boil number 4. You can see there's our gold. What I'm going to do now is add some distilled water to this. And then we're going to put some more nitric acid in here. I'm going to set it back up on the heat and let this continue to boil. This will be the 5th nitric acid boil. Remember, the nitric acid does not go to waste in any of these processes. I use every single bit of it to dissolve all the silver that I have. Let's stick him right back up on the heater there. This is the 5th nitric acid boil, and we're going to pour that active nitric off and save it. We can use it again in a future refining. Then I'll rinse out the rest of the nitric off the gold and add it to my silver jar. If you notice, the nitric acid's got a little bit of green tint, indicating I may have some palladium in that solution. So I'll save it. Now I'm going to add hydrochloric acid to the gold. Then we'll add a little bit of sulfuric acid. This will precipitate out any lead so it can be filtered out. And now I'm going to add about 15 milliliters of concentrated nitric acid to form aqua regia in the beaker. Now I'll cover it up, give it a swirl to stir it up, and put it up on the heat, let it dissolve. The gold has been on the heat now for about 20 minutes. What I'm going to do is start adding small amounts of concentrated nitric acid. It's going to be real hot here, so I got to add this very slowly. Otherwise, we could get a runaway reaction. That was maybe 10 drops right there, just to show you how reactive this stuff is. When it's hot, you gotta add the nitric real slow. I'm using incremental nitric acid dosing here rather than mixing or pre-mixing the aqua regia 3-to-1 or 4-to-1. If we pre-mix the aqua regia, we're guaranteed to have problems with excess nitric when we go to precipitate. So if you add just enough nitric to just dissolve the gold, then there won't be any excess nitric to remove. Pull this down off the heat now. And what we'll do is I've got some ice here, and we're going to add ice to the solution. This will do two things for us. This will cool it down, and it will cause, get over here, the silver chloride, if any, if present, to come out of solution so that we can filter it out. I'm going to perform a test here. Dip a piece of filter paper in the solution, and you can see the stannous test verifies that we have gold in solution. I've been getting a lot of comments from people saying they can't get their gold to come out of solution. Well, before we can precipitate this gold, we want to make sure that we have gold in solution by testing it with some stannous chloride testing solution. I'm going to add a little bit more water here just to make sure that we've got all of our silver chloride to come out of solution so we can filter it out. I've got a filter installed in my Buckner funnel here. Now what we'll do is go ahead and filter the solution. Everything's been pulled through the filter. You can see there's a little bit of trash that we filtered out. Now what we'll do is get the filter flask funnel here out of the way. Solution does not look bad at all. Fairly clear. This is going to be the first refining, so we're not going to be real particular about the high clarity that we usually seek. Alright, here we go. We're going to precipitate our gold, but first I'm going to start making it a habit to check the solution with some stannous chloride before I do the precipitation. It's very important to do this because if you don't have any gold in solution, it might look like you do, but if you don't have any gold in solution, then there's no point in trying to precipitate any out. That stain right there verifies with a stannous test that I do in fact have gold in this solution. Alright, here we go. We're going to precipitate the pure gold with sodium metabisulfite. Here we go. Okay, I think we've got it all now. Alright, we're going to verify, make sure I've got all of the gold out of solution. Get a little bit of the solution on a piece of filter paper. Test it with some more stannous chloride. As you can see, zero reaction. That means that all of the gold has been precipitated out now. I've allowed our gold to settle overnight, and now what I'm going to do is pour this waste solution off into a temporary waste container. There's our gold. Notice that the liquid over the top of it has a slight tint, which means there's probably traces of metals in that liquid. So I'm going to pour it into this temporary waste container, save it, and add it to my stock pot. You'll notice that there's a little bit of gold in the bottom of the waste container down here. A little bit gets poured over with this waste. It's okay. I can always recover it later. Okay, here's our pure gold powder, first refining. I'm going to rinse the pure gold powder with hydrochloric acid. Folks have written in the comment section, why do you call it hydrochloric acid when it clearly says muriatic acid? Because muriatic acid and hydrochloric acid, just two different names for the same acid. You'll notice that the solution appears cloudy, and that is from the excess sodium metabisulfite being rinsed off by the acid. So we'll just pour this off now. If a little bit of gold goes over, again, that's okay, no problem. Sodium metabisulfite is soluble in water, so just plain water washes would work here, but I like to use hydrochloric because it does a better job at rinsing dissolved metals out than water does. And you can see here how the gold powder settles quickly, rinses out nicely. It's got a nice caramel color to it, which is what we want to see. And now what I'm doing is just rinsing it repeatedly with just distilled water. Very nice. I'm going to add some hydrochloric acid to the gold now, about 200 milliliters or so. And what we'll do is cover this up now, set it up on the heat, and just let it boil for a minute up on high heat. The gold has been on here boiling now for about 10 minutes or so. What we're going to do is pour it off now into our temporary waste container. Notice it's got a little bit of a yellow color to it. If some of the gold went back in solution, which is highly possible, then that's okay. When we pour it into our waste container here, there's SMB in this, and any gold that went in solution will precipitate back out and settle out in our waste container. Alright, I'm going to rinse this off with some water. Get all the acid rinsed off that I can. Look at that beautiful gold powder, man. Nice caramel color. Settles quickly. That's high purity gold already, right? Just like it is. I'm going to add about 350 milliliters of hydrochloric. I'm going to add some sulfuric acid just in case any lead made it this far. Highly unlikely, but I always add it anyway. Hurts nothing, provides a big benefit. I've got just under 400 milliliters of hydrochloric in here. Now what we're going to do is measure out about 30 milliliters of nitric acid, concentrated nitric acid. And we're going to add that right on in. Stir it up. Put it up on the heat and let it start boiling. I'll begin adding small amounts of concentrated nitric here, a little bit at a time, because this is going to be real hot now, as before, and we could get a boil over if we shoot that in there too quickly. But what I want to do here is add just enough nitric acid to just dissolve the gold. If I do this right, all the gold will be gone and there won't be any excess nitric acid in our solution. Like everybody else, when I first started doing this, I felt the urge to throw a whole bunch of urea in there to try to rid it of excess nitric. And it was Butcher on the Gold Refining Forum that finally convinced me that adding urea to your gold solution is not the way to go. Incremental nitric dosing says it all. All right, here's our beautiful, clear and bright chlororic acid solution. No sediment, no cloudiness. I'm going to pull it down and I'm going to let it cool off just a little bit here. And we'll do a hot filtration just for good measure. And then what we're going to do is we're going to precipitate the gold with oxalic acid. Drawing a vacuum on this flask. And what we're going to do now is just filter this hot solution. There's probably no need to do so because it's very clean. But just for good measure, for the sake of purity, I'm going to go ahead and filter it out just in case there's any junk in here. Hot filtration under vacuum. You can see the liquid pull through the filter very quickly. Here you can see the solution is very clear. No traces of cloudiness. The filter paper is pristine. Just about the same condition as when we put it in. So it's going to make some high purity gold right here. Alright, we're going to transfer our solution out of this flask and into a clean beaker that I have prepared for it. It's still hot, and we need these solutions hot, in fact boiling, to do the reaction with the oxalic acid. And that's why I didn't cool it down. I just left it hot to do the filtration. And what we'll do is stick this now up on the heat and start heating this up in preparation for precipitation with oxalic acid. Before we get started, I just want to show you how clear and bright this solution is. You can really read the label right through the solution. I mean, it is absolutely high purity gold, just like it is right here. And when we get done with this oxalic acid precipitation, it should be very close to 4/9 fine. Here's the procedure that I'll use to precipitate the gold. This is in Hoke's book, page 173. And you can pause it and read here if you'd like. I'm not going to read the entire sequence, but I'm going to try to display it here on the video so you can see exactly what procedure that I'll be using. Bottom of page 172, it says sulfur dioxide, which is the same thing as sodium metabisulfite, tends to carry down traces of platinum group metals with the gold. Oxalic acid does not, but oxalic acid does tend to carry down tin and copper if they're present, whereas sodium metabisulfite or sulfur dioxide does not. We're going to prepare our oxalic acid solution here. I got this at Ace Hardware. It's got 12 ounces, so I'm going to empty about half of this into this beaker here, and then we'll dissolve it in some water. Looks fairly clean, but I'm going to probably go ahead and filter it just to make sure there's any sediment or anything in here that could foul our reaction. That's about half of it, so that'll be about 6 ounces. I'm adding distilled water to dissolve the oxalic acid now. We'll set this up on the heat. got real cold, so it's an endothermic reaction. We're going to go ahead and put this on the heat, try to get it to dissolve completely. All of the oxalic acid has dissolved, and now what we need to do is raise the pH. The book says to do it with ammonia, but I'm going to use sodium hydroxide instead. Have to add this slow or probably get a boil over here. Here we go, just a little at a time. Making a hissing noise as I add it. Probably adding some heat to the solution also. I've rinsed the beaker out. You can look down in the filter here. You can see there's a little bit of trash. So it was a good thing we did that. Now what we'll do is I'll add the solution back to the clean beaker. It's still hot. And now we'll pour or put our solution back up on the heat and let this come to a boil now. While I wait for my solutions to heat up back here, I've got a small beaker here. I'm gonna prepare some more sodium hydroxide solution here. I don't think the amount of lye that I added to that oxalic acid is going to be sufficient, so I'm going to make up some more lye solution here, filter it, and have it standing by when we go to add the oxalic acid. We got this solution boiling. I've been waiting for 20 minutes. And this is just under a boil, so I don't think it's going to be able to get hot enough back here. Turn this burner off, and we're going to transfer the solution, the gold solution, to a different burner. Hopefully it'll get hot enough to cause this solution to boil in just a few minutes. Then we'll go ahead with the precipitation. Both solutions boiling. Here we go. I'm going to pour the oxalic acid into the gold solution. Here we go. Let's see what's going to happen here. I don't have much experience doing this. I'm not going to pour it all in all at once. I don't want to risk a boil over. I'm going to add a little bit of our lye solution to this carefully. Whoa, there it goes. There it goes. Got to add that real slow here. That's the trick, is getting the lye in there without causing it to spatter real bad. I probably should have used a bigger beaker, like a 4-liter. Plus I see fumes, So we're probably dealing with just a touch of excess nitric in there. I'm going to add a little bit more of the oxalic acid. This should be an excess of oxalic acid here. Alright, I can see something starting to happen in here. What I may do is just put this on time lapse. There it goes. It's starting to precipitate out now. I've got probably about half of the oh, that's making a nice texture there. I've probably got half of the solution in there now. I just added that. That was lye that I added just now. I'm gonna add a little bit more. That helps. You can see it's causing our gold to start coming out of solution now, which is what we want to see. I'm going to add a little bit more of our oxalic acid. I want to make sure I got enough of this in there. That's oxalic acid going in now. Alright, I'm going to add a little bit more lye here. We're making progress. But I got to tell you, I prefer using sodium metabisulfite big time, man. This is a giant pain in the you-know-what here. Adding more sodium hydroxide now. Just tiny bits down the side of the beaker. Try to get all this gold to come out of solution. Seems to work better when I let it drip down the side of the beaker like that. I don't know why, it just does. Take a look at this, man. I got gold spattered all over the dish. Some up on the wall of my fume hood. It's clinging to the dropper that I was using to add sodium hydroxide. I do not like precipitating gold with oxalic acid. I just don't like it. This is the reason why. It's messy. Giant pain here. I'm going to try to rinse down the side of the beaker here with some water. It's going to cool my solution down. Alright, I'm going to reach in here and give it a quick stir. That's our big chunk of gold there. It's going to be ultra high purity gold, but man, getting it is no piece of cake by any means. Had a little over 3 troy ounces of gold in there and only about 400 milliliters of solution. We'll try to dilute it a little bit with some distilled water. We'll bring this back up to a boil and see if that'll help us. That's lye I'm adding right there. Diluting the solution seems to have helped. Alright, I think what I'll do here is just pour the rest of the lye solution right on in. See if we can get the rest of this gold to come out of solution. All right, as usual, I'm out of my experience level here. It's been a long time since I tried to precipitate any gold with oxalic acid, let alone this amount of gold. There's like a little over 3 ounces here. So I went in and got myself something to eat, and I just let this thing boil. Imagine my relief when I came back out and I seen that everything had dropped, all the gold had precipitated. Thank you. This has been boiling away for about 2 hours now. You can see the gold sponge accumulated on the bottom of that beaker. It looks fantastic. This is very similar to the gold powder that we get when we just use sodium metabisulfite. But it is more of a spongy texture there. And if you notice, the solution is cleared up nicely. Still got a little bit of gold in solution. If we let this boil, it would probably clear up. Get in here, let's see. Set this back up out of the way. And move this heater out of here. Don't need this anymore. Gold off of the side first. Alright, let's just go ahead and pour this right on into our temporary waste container. Look at that, man. Waste turned bread from the oxalic acid. Alright, what we'll do is start rinsing off our sponge. It's our gold sponge, man. It really looks weird, doesn't it? Actually, it looks like a sponge. Huh. Alright, here we go. We're gonna start rinsing all this off with some hydrochloric acid. Look at that thing, stays together in one hunk, just like a sponge, man. Look at that, man. That's weird. Wow. Break it up with a glass rod here. I'm not used to working with gold that's been precipitated with oxalic acid. It's a little different than what I'm used to working with. What I'll probably end up doing here is redissolving this a third time. But you know that's got to be high purity gold, man. Oxalic acid precipitated, probably close to 4/9 fine. I'll rinse this down, and what I think I'm going to do here, pour this waste off into my temporary waste container here. It's clumped together fairly hard, does not want to come apart, but Sweet Tips is going to force it to come apart here in a minute. Okay, there's only one way to deal with this, and that's to dissolve it one more time So I'm adding about 350 milliliters of hydrochloric. I'm going to measure out about 40 milliliters of nitric acid, and we're going to throw that right on in here. Alright, we're going to cover this up and put this up on some heat now and let this dissolve. I'm not going to show the whole dissolving sequence again. It's already been shown twice. I'll come back when we've got the gold in solution. It only took about 10 minutes to put everything in solution. I'll pull it down off the heat. We're going to let it cool down. I'm going to add some ice cubes, and you'll see there's no silver chloride formation whatsoever in there. And now we'll go ahead and filter it. Probably not necessary, but I'm going to do it just for good measure. If you look, there's absolutely nothing in the filter, and the filtrate is crystal clear, no traces of contamination. Some of the purest gold I've ever refined. I just can't get over how clear that solution is. This will have to be some of the cleanest gold that I've ever produced. Now we're going to add sodium metabisulfite, and if you watch here, about 2/3 of the way in, here in just a second, I thought I seen a slight tint of purple in the foam. As I'm adding the spoons of sodium metabisulfite, eventually what will happen is we'll start getting some foam on the surface. And the very first time it does it, I thought I caught just a glimpse of purplish colored foam. Coming up, I think it's this one right here. Right there. Looked like purple, which purple is the color of gold. So I'm really excited about this batch of gold. It's going to be really, really pure. Settled completely. Solution over the top of it's nice and clear. I'm going to pour off the waste solution now into this temporary waste container. Okay, here we go. Adding some hydrochloric acid to the gold. I'm going to set it up here on the heat and give it a quick boil. It's been on boiling now for about 10 minutes. Looking pretty good, man. The solution is nice, clear and colorless. What we're going to do now is take and pour this solution off. See that? Didn't yellow like the last time. Pour this off now into our waste container and get our pure gold. Man, that's going to be some of the highest purity gold that I've ever produced. Looks absolutely beautiful. That pure gold, man. Almost looks red. I'm gonna start rinsing all the acid off of this gold now. Look at that color of that gold, man. It is just beautiful. And we'll just do multiple hot water rinses now on our gold until we get all the chemicals rinsed off. And that stuff just looks gorgeous. You can see got some of these little cheap pH test strips here. And we're almost at a pH of 1 according to this test. All right, I've had about 2 liters of hot distilled water. Let's get a reading here. Bang, I'm calling that neutral, man. We're good. I've got all the chemicals, all the acid rinsed off of that gold. Here we go. We're going to pour off the final rinse. And get this gold. Look at that stuff, man. I have never seen gold look that beautiful before. All right, we're going to pour off this water. And then, ouch. All right, let's see if we can transfer our gold down into this nice, clean, brand new beaker. Pristine. Look at that, man. It just slipped right in. And I'm going to get this on some heat and slowly evaporate the water so we can dry the powder. All right, I'm going to fill this little dish up with some water so we don't boil and spatter the gold in there. And now what I'll do is I'm going to put this up here on the heat, and we're going to let this slowly dry. Most of the moisture has been evaporated off now in that steam bath. So I'm going to take the steam bath off of the heater, and we're going to put the beaker of gold powder directly on the heat. A few minutes later, and our pure gold powder is bone dry. Our pure gold powder, and I've got to be honest with you, I've been refining gold for 10 years, and I don't ever remember seeing anything that quite looks like this stuff looks. It is just incredible. It's high purity gold powder. It's probably close to 4/9 fine here. What I'm going to do now, after I get done gawking at it, man, it is just incredible. I don't know if the camera does it justice here, but you could probably cold press this in a hydraulic press into a solid bar of gold. It's just incredible. Look at that, man. It's unbelievable. All right, we're going to try to do something here. See if I can pull this off. I've got some small containers back here, little jars with a lid. And what I'm going to do here is I'm going to put one of these on the scale. It's 5.7 grams. Can you see that? 5.7 grams. I'm going to tear that to 0. All right, let me see if I can reach in here and get some of this gold in this little scoop. I don't know how this is going to work, but I'm going to try to get a gram of this material, this gold, into a little container here. Let's see, how much is that? It's 0.3 grams, so I got a little ways to go here. Come on, here we go. There's a nice chunk. Point 0.6. Point 0.8. Almost there. Just a touch more, and we'll have 1 gram in here. See if we can make that happen. One gram. Beautiful. All right, I've got 1 gram of this ultra high purity gold powder in this little container. So what we're going to do now is offer these for sale 1 gram at a time on my eBay store. Wow, what a journey. Somebody wanted to see oxalic acid precipitation, and now we've got that under our belt. Pretty good experience. And we got some absolutely gorgeous, it's orange, absolutely gorgeous, high purity gold sponge, gold powder. All right, we're going to be offering these for sale on my eBay store. That'll conclude the video. Thanks for watching.